introducing myself, my name is Joseph. I'm Veaugh-Geiss. I work for KDE in a project that's also funded by the Umweltbundesamt, or the German Environment Agency, and the BMUV. We are a project, it's called Blauer Engel for Veaugh-Geiss. And I want to start, so I'm going to talk about the implementation of the Blue Angel criteria for ocular, as well as some of the things that we're doing to enable other free software projects to measure and certify their software. Before I get started, though, I want to start with a very high level, what is free software? And instead of asking people what they know or don't know, no one wants to admit they don't know something. I thought I'd just give a slide or two and just introduce what free software is for those who are not software developers and maybe unfamiliar with the term. We also use a green leaf sort of logo with our KDE symbol popping out from the background. All of our slides, if you're interested, for our talks are available at our GitLab repository, and you can, I guess, also get them from Max if you're interested. So to start with, what is free software? So a programmer writes a software program in source code using a human-readable programming language. And a program is just a recipe of commands that tells the computer, the hardware, what to do. That consumes energy. That's the whole point of what we're talking about here. A compiler will translate that human-readable code, something that looks like this, hello world in C, into a machine language in ones and zeros. So even if you don't program, you can probably understand what this code is doing, at least on some level. If you get to the machine language, the binary, this is completely uninterpretable for humans. The process of translating the code into machine language, again, is done with the compiler. When you are downloading a binary, you're just getting the ones and zeros. You don't get access to that source code. With free software, through the licensing, you're guaranteed to get access to that source code so that you can use it as you want, study it, learn from it, share it with others, and improve it. Okay, and that's the 4 freedoms of free software. And the reason I start with that is our project is recognizing how the Blue Angel, it doesn't require software developers to develop free software, but free software has several advantages. Things that we take for granted in user autonomy are a big part of the holistic approach to what sustainable software looks like, which I'm going to get into now. So just to review, it's sometimes good to repeat things. This is what I'm calling the ABCs of the Blue Angel Award criteria for desktop software. Just reducing it here to, so this is repeating what Jens just said, but in a slightly more condensed way. So the potential hardware operating life and user autonomy criteria are criteria that free software is generally already fulfilling. We take many of these characteristics that the Blue Angel is now recognizing as being more sustainable, we take them for granted, right? This is what free software does. We give users the ability to uninstall what they don't need, to install what they need, transparency and open standards. These are all things that free software is already doing. Running on hardware that's at least 5 years old, I would challenge the German Environment Agency to even make that a bit higher, because many free software distributions can run on hardware that's much older than that and continue to be used. Of course, you need to find the sweet spot when replacing old hardware is worth the embodied carbon that comes with replacing it and the energy efficiency that's lost by using old hardware. But it's, 5 years is actually quite, it's again, a given in the free software community. And the application process really requires, for free software developers, making the energy consumption transparent. And I've been, so in the project, we're spreading information to free software communities about eco-certification with the Blauer Engel, and sort of reducing this to the 3 steps to eco-certification: measure, analyze, and certify for free software projects. How do you measure? So this is a lab setup environment. Here you have, I don't have a, So the system under test, the far left there, is the hardware that you want to test the software that you're going to eco-certify on. There are recommended operating systems that from the Blue Angel to test the software. This is then connected to a power meter and then another computer that are collecting the data from the power meter as well as from the hardware usage on the system under test. A power meter, so the Gouda power meter, the one that Arna presented earlier, is the one that we are setting up in a lab here in Berlin. But you can use other recommended power meters like the Janitza power meter. That was the one used to measure ocular. You can also, if you're just interested in taking a little bit of time and 10 euros, you can also hack a power plug, which Volker has documented how to do to get some pretty low resolution but usable data to get an idea of what your actual usage does when you're using your computer in terms of the energy consumption. That was not the end of the slides, but the next slide. Okay, so we are setting up a community lab here in Berlin. This is from the last sprint in August. The lab will be available to free and open source software developers to measure software. Right now, it's a proof of concept. We have donated hardware just to get the lab running so we can see that it's working. Again, using hardware that's from 2011, and it works fine. So you can use very old hardware, but we're going to update that to fulfill the requirements of the Blue Angel. The things you need to measure, as was already mentioned, you have 3 scenarios that you need to measure. The baseline, which is just the operating system running without anything else happening. Ideally, you will turn off any background processes like automatic updates and things like this that can influence the energy consumption. Your idle mode, which is the operating system with the application running but not doing anything. And then your standard usage scenario, which has been brought up a couple of times now. It's the representation of what average users do when they use that software. You also, so to emulate user behavior, there are various tools you can use. The one that was used for Ocular was Acciona, which is a sort of click and point based tool. That is easy for new users. It doesn't require much programming understanding. You just sort of click and it records what you did. It's not very robust when you're moving it across different systems, which, if you're preparing it on one computer and moving to another to measure, that might create a problem that you have to redo every click and point since the pixels might be different. If you want to measure it later to replicate the measurements at a future date, again, you might have a problem of transferring that script to another computer. So some of the tools that we've been working with in KDE are XDo tool, and then one of the developers developed a tool using XDo tool with Python, which he's calling KDE Eco Tester. This is a tool that's based on, so it only works in X11, which you can give commands through the command line and it will do actions. It's much more robust. You can transfer it across computers. It's not based on the pixels, but rather on command shortcuts. We also are interested in developing other tools for emulation. There's a proposal right now to work with Selenium. I'm not a developer myself, so I can't say much about that, but this is a more robust system, also can work on Wayland, which we're also interested in testing. So it can allow us to move beyond just X11, but also into Wayland. Once you've defined your usage scenario, things like opening a PDF, scrolling through the pages, turning it right and left, zooming in, zooming out, things like this. You have your data. You then take that data and you can use a tool like Oscar. This is what was used for Ocular. This is the open source software consumption analysis in R. It was developed by the Umweltcampus Birkenfeld. You upload your log file of actions and your energy consumption or hardware performance data. There are some things you have to be careful of in preparing the data so that it can be read by the script. It's not the only way you can do it, but this is certainly a very accessible way. This is an example of Ocular from the report given by Oscar. Here you see 31 repetitions. When you run your measurements, do it several times so you can get the signal and the noise. And then It's then, and here you have the power consumption on the y-axis and the time on the x-axis, and you can see that there are points that spike. This is, for example, when zooming in or zooming out and things like this. So now we have the measurements and the report. For free and open source software developers, this largely just means documenting the compliance with the award criteria for the A and the B and submitting the report for C. An example of the type of documentation, this is related to the continuity of updates. Here we provide information about the release cycle for Ocular, the fact that it's open source, that it can be continued to be developed beyond whatever involvement KDE has, but there's no intention to stop developing at any point. Again, you don't need to be free and open source software to do this, but we are in many ways already fulfilling many of these criteria. So yeah, we submitted our application in December. 2 to 3 months later, RAL reviewed it, and then we were awarded the first eco-certified computer program with the Blue Angel, the first in the global eco-labeling network. And we're very proud of this, and we'll have our award ceremony next week on Wednesday in Hamburg at the EnviroInfo conference. So if you are in Hamburg and want to come, please do. We're also working on things beyond just the Blue Angel, and I thought I'd just mention one thing that is quite interesting is this live plotting. So I mentioned these cheap power plugs. You can combine that with a free software tool like LabPlot, and you can see as you're doing things with your computer what the energy consumption is. And this could be a nice awareness-raising tool for making users aware of what they're doing, how it influences energy consumption. If you want to get involved in our KDE Eco project, here's some information, and you can get that from Max or me at a future date. So just to finish on the slide that we are also funded by the Umweltbundesamt and BMUV. So thank you.